I'm very excited to announce our next speaker. He's a professor of computer science at Carnegie Mellon University. He's an expert on crowdsourcing, and he's going to talk to us about his work on the computational power of humans. Please help me welcome Dr. Luis von Ahn.
Hi, can you hear me now? Okay, good. Okay, I want to start by asking you guys a question. How many of you have had to fill out some sort of web form where you've been asked to read a distorted sequence of characters or a distorted word such as this one? How many of you found it really, really annoying? Outstanding. I invented that. That thing is called a CAPTCHA. And the reason is to make sure that you, the entity filling out the form, are actually a human and not some sort of computer program that was written to submit the form millions and millions of times. And the reason it works is because humans, at least non-visually impaired humans, have no trouble reading these distorted squiggly characters, whereas computer programs simply can't do it as well yet. So for example, in the case of Ticketmaster, the reason you have to type these squiggly characters whenever you're buying tickets online is to prevent scalpers from writing a program that buys millions of tickets two at a time. Okay, now CAPTCHAs are used all over the internet, and since they're used so often, a lot of times the precise sequence of random characters that is shown to the user is not so fortunate. So for example, let me give you this. This is an example from the Yahoo registration page. These characters are supposed to be random. The random characters that were shown this time happen to be W-A-I-T, which of course spell a word. But the best part is, this was shown, and about 20 minutes later, somebody at Yahoo got this email. Okay, so they thought they had to wait. This, of course, is not as bad as this poor person who restarted their computer. Okay, now more generally, a CAPTCHA is just a program that can tell whether its user is a human or a computer. Let me say that another way. A CAPTCHA is a program that can generate and grade tests that most humans can pass, but current computer programs cannot. Okay, so notice the paradox here. A CAPTCHA is a program that can generate and grade tests that it itself cannot pass. Okay, so in that way, CAPTCHAs are a lot like some professors. You can do that. Now, CAPTCHAs, since they're used so often, they have all kinds of applications, and I could spend the next hour talking about all the different applications, but since I don't want to do that, let me illustrate one of the applications through a little story. It's the following. A few years ago, Slashdot, which is a very popular website for nerds like me, put up this poll in their site asking, which is the best computer science graduate school in the United States? And if you think about it for a second, this is a really dangerous question to ask over the internet. Because as soon as the poll went up, students at Carnegie Mellon wrote a program that voted for Carnegie Mellon millions and millions of times. The next day, students at MIT wrote their own program, and a few days later, the poll had to be taken down because both CMU and MIT had more than 6 billion votes. and every other school had less than 1,000. So if you think about it, the poll did exactly what it was supposed to do. But in general, we simply cannot trust the results of an online poll because anybody could just write a program to vote for their favorite option. Now, this is one possible application of CAPTCHAs. If you put a CAPTCHA in there, you can ensure that only humans can vote. Okay, so CAPTCHAs can be used to make polls better. Another application of CAPTCHA is in free email services. So there's a lot of companies out there that offer free email services, Yahoo, Google, Microsoft, etc. And up until a few years ago, all of these companies were suffering from a very specific type of attack. And it was people who wrote programs to obtain millions and millions of email accounts every day. And the people who wrote these programs were spammers. So here's the thing. If you're a spammer, it's actually quite worthwhile to send spam emails from Yahoo accounts because nobody's going to block all of yahoo.com. So it's actually quite worthwhile to send spam from Yahoo. But if you're a spammer, you run into the problem that each Yahoo account only allows you to send like 100 messages a day. So if you want to send 10 billion spam messages per day, like spammers do, they had to obtain millions of email accounts from which they could send like 50 spam messages each one. So this is why spammers wrote programs to obtain millions of email accounts every day. And the solution, and this is what we originally told Yahoo about 10 years ago, was to put a CAPTCHA in there to make sure that only humans can obtain free email accounts. Okay, so in general, CAPTCHAs are used to stop spammers from doing bad things on the internet. Now, of course, spammers on their side have started coming up with all kinds of dirty hacks to get around the CAPTCHAs that are being used in practice. Let me show you a couple of them. Here's one. This is something we call CAPTCHA sweatshops. So spam companies have actually started hiring humans whose sole job is to type CAPTCHAs all day long. This is currently happening. This is usually happening in other countries where the minimum wage is a lot lower, but it is happening. But there's at least two consolations. First, it's at least costing them some. So whereas before they could get millions of email accounts for free, now they have to pay a fraction of a cent per account, so they can't get that many. Second, if you think about it, CAPTCHAs are actually generating jobs in underdeveloped countries. Okay. Okay, so this is what some spam companies have started doing. Let me tell you an even dirtier hack, and this is what some pornography companies have started doing. Okay, so there's a lot of pornography on the internet, and pornography companies also want to send spam, and here's how they're doing it. It's really clever. Here's what they do. Imagine there's a pornography company that would like to send you spam from Yahoo accounts. So what they need to do is they need to obtain millions of Yahoo accounts. So what they do is they write a program that fills out the entire registration form at Yahoo. Now, whenever this program gets to the CAPTCHA, you can't read it. So what it does is it copies the CAPTCHA to the porn page. Now, back at the porn page, there's a lot of people looking at pornography. And suddenly one of them gets this screen saying, hey, if you want to see the next pornographic image or pornographic video, you got to type the word that's in the box below. And you know what people do? They type the word as fast as possible. And by doing so, they are effectively solving the CAPTCHA for the porn company. That is, they are effectively obtaining an email account that the porn company can later use to spam you. Okay, so pornographers, they're very clever people. Okay, so let me now show you something else. So the idea of a CAPTCHA, as I said, is a lot more general. It's just a test that can distinguish humans from computers. The one that everybody has seen is the squiggly characters, but it doesn't have to be squiggly characters. It can be any test that distinguishes humans from computers. Let me show you a few examples of CAPTCHAs that other people have come up with, mainly because I find them very interesting. So for each one of the examples that I show you, you need to think of two properties. A CAPTCHA needs to have two properties. First of all, it must be the case that all humans can do it, or at least 99% of the human population can do it. And second, it must be the case that computers cannot do it. Okay, so let me show you a few of these. So the first one is a CAPTCHA that started coming up in all kinds of Russian blogs. We're going to call this the Russian CAPTCHA. You have to solve a limit. It's funny to see that they think 99% of the population can do this. I guess it's true in Russia. Of course, this is a pretty crappy CAPTCHA because computers can actually do this pretty well. But it's funny to see that they think this is a valid CAPTCHA. So that's the Russian CAPTCHA. Let me show you one that started coming up in all kinds of Indian sites. We're going to call this the Indian CAPTCHA. You have to analyze the circuit. Again, it's pretty funny to see that they think anybody can just do this. Of course, computers can actually do this. So now, just to give you a comparison, let me show you. So in Russia, you have to solve a limit. In India, you have to analyze the circuit. Let me show you a CAPTCHA that started recently coming up in all kinds of US-based blogs. We're going to call this the American CAPTCHA. I wish I was making this up. I'm not. Okay, again, this is a pretty crappy CAPTCHA. Computers can add. Okay, so I could tell funny stories about CAPTCHAs for hours. Let me tell you the next project that we worked on after this. It's a project called reCAPTCHA. We started it about 3 years ago, and it's sort of the future of CAPTCHAs. And it's a project that started at Carnegie Mellon University as a research project. Then we turned it into a company, and then the company was actually acquired by Google last year, so now this is property of Google. So let me tell you what this project is all about. So here's how it started. It started from the following realization. It turns out that about 200 million CAPTCHAs are typed every day by people around the world. Okay, I type a CAPTCHA roughly once every 3 or 4 days because I use the internet very heavily. And it turns out that if you add it all up, it's about 200 million times a day. Now, when I first heard this number, I was quite proud of myself. I thought, look at the impact that my research has had. But then I started feeling bad. See, here's the thing. Each time you type a CAPTCHA, essentially, you waste 10 seconds of your time. It takes about 10 seconds to type one. And if you multiply 10 seconds by 200 million, you get that humanity as a whole is wasting about 500,000 hours every day typing these annoying CAPTCHAs. So then I started feeling bad. And then I started thinking, what can we do about this? Of course, we can't just get rid of CAPTCHAs because the security of the web sort of depends on them. But then I started thinking, is there any way in which we can use this effort for something that's good for humanity? So here's the thing. During those 10 seconds, while you're typing a CAPTCHA, your brain is doing something amazing. Your brain is doing something that we cannot yet get computers to do. So this is a very valuable 10 seconds. So can we get you to do useful work during those 10 seconds? Another way of putting it is there's some humongous problem that we cannot yet get computers to solve, but that somehow we can split into tiny 10-second chunks such that every time somebody types a CAPTCHA, they solve a little bit of this problem. And the answer to that is yes, and this is what we're doing now. So what you may not know is that nowadays, while you type a CAPTCHA, not only are you authenticating yourself as a human, but in addition, you're actually helping us to digitize books. Okay, so let me explain how this works. So there's a lot of projects out there trying to digitize books. Google has one, the Internet Archive has one, Amazon with a Kindle is now trying to digitize books. And basically how it works is you start with a book, an old book, like a physical book. You've seen those things, right, the physical books. And then you scan it. Now, scanning a book is like taking a digital photograph of every page of the book. It gives you an image for every page of the book. The next step in the digitization process is that the computer needs to be able to decipher all of the characters in this image so that you can search through the content of the book. That's done using a technology called OCR, for optical character recognition. The problem with OCR is that it's not perfect, especially for older books where the ink has faded or the pages have turned yellow. The characters don't quite look the same anymore, so the computer cannot recognize them. Okay, so for example, if we get the computer to try to recognize all the characters in this image, here's what we get. So in yellow are all the mistakes. For things that were written more than 50 years ago, the computer cannot recognize approximately 30% of the words. So about a third of the words, it just cannot recognize. So what we're doing now is we're taking all of the words that the computer cannot recognize, and we're getting people to read them for us while they're typing a CAPTCHA on the internet. Okay, so the idea is the following. We start with a scanned book. Then we take all the words that the computer cannot recognize. Now, how do we know which words cannot be recognized by the computer? It turns out that the computer tells you whenever it cannot recognize a word. It says, here's a word, this is my best guess for it, but I'm not very sure about it. Okay, so we take all the words that the computer cannot recognize, and we're going to use these as the basis for a CAPTCHA on the internet. Okay, notice these words are perfect for a CAPTCHA because these are by definition words that the computer could not recognize. Okay, so we're going to take this word, we're going to distort it even further to make sure that a computer cannot recognize it, and now we're going to use it as a CAPTCHA. So for example, whenever you're trying to buy tickets on Ticketmaster, you're going to get this word that comes directly out of a book that the computer could not recognize. And whatever you type, we're going to use it to actually digitize books. Now, some of you may be wondering the following. Wait a second. This is a word that we just took out of a book. The system did not know what it was. Now it's going to present it to somebody trying to buy tickets on Ticketmaster, and it should be the case that if they type the word between, they let them in. You know, the system lets them in, but if they don't type the word between, the system shouldn't let them in. But how can the system do that if this is a word that it just took out of a book that it doesn't know what it is? Okay, so, you know, in other words, how can it grade the test? And the solution to that is that whenever we take a word for which the system doesn't know the answer, what the system does is it actually presents it to a human along with another word, one for which it does know the answer. Okay, so we're going to give people two words, one for which the system knows the answer, one for which it doesn't. We're not going to tell people which one's which, and we're going to say, please type both. And if you type the correct word for the one for which we already knew the answer, we assume you're a human. And we also get some confidence that you typed the other word correctly. And if you repeat this process to like 10 different people, and they all type that the new word is the word between, then we get with overwhelmingly high probability that the new word really is the word between. So this is why one more word becomes digitized through reCAPTCHA. Okay, so thank you. So what we did about 3 years ago is we created this thing called reCAPTCHA. It's a web service where the idea is if you're a website like Facebook that needs CAPTCHAs to protect yourself against spammers, then you can come talk to us, and reCAPTCHA will give you CAPTCHAs for free. The only caveat is that we get to see what the users are typing so that we get to digitize books. And ever since we did this, a lot of websites have started switching from the old CAPTCHA where people wasted the time to the new CAPTCHA where people are helping to digitize books. So for example, Facebook has switched, so whenever you add friends, whenever you poke people, you help to digitize a book. Ticketmaster, whenever you buy tickets, you help to digitize a book. Craigslist, Twitter, and about 300,000 other websites have all switched from the old CAPTCHA to the new CAPTCHA. So a lot of words are being digitized. In fact, so many websites are using reCAPTCHA that the number of words that we're digitizing per day is extremely large. So here's a graph. It's a little old. By now, we're digitizing, I think, about 85 million words a day by just having people type CAPTCHAs on the internet, all for free. Now, this is the equivalent of about 2 million books a year being digitized one word at a time by people throughout the internet. Okay, so that's that. Now, of course, since we're doing so many words per day, again, funny things can happen. And this is especially true because, see, now we're presenting people with two randomly chosen English words right next to each other. So, for example, we presented this word. It's the word Christians. There's nothing wrong with it. But if you present it along with another randomly chosen word, bad things can happen. So, for example, we showed this. It's kind of bad. But it's even worse because the particular website where we show this happens to be called the Embassy of the Kingdom of God. Oops. These are randomly chosen. There's nothing we can do. So that's one. Here's another one, johnedwards.com. Of course, there's nothing much we can do against this because one of the words, we don't actually know what's in there, right? So we can't really stop it. So we go around insulting people left and right every day. Okay, now I'm sure some of you are thinking the following. wait a second. You started by saying that humanity as a whole is wasting 500,000 hours every day on these annoying CAPTCHAs, and your solution is to double that amount of time by having people type 2 words instead of 1. It's a very good thought to have, but you're wrong. And here's the thing. It turns out that typing 2 randomly chosen English words takes equally as long as typing 6 to 8 random characters. Okay, previous CAPTCHAs used 6 to 8 random characters. Now we're giving 2 randomly chosen words. Because words have patterns associated to them that we're all accustomed to, we type words much faster than random characters, so the amount of time hasn't actually increased. In fact, it has slightly decreased. Okay, so that's good. Here's another one. This is a number that I really like. This is the total number of distinct people throughout the world that have helped us digitize at least one word out of a book with reCAPTCHA. So 750 million people, which is equivalent to about, it's a little more than 10% of the world's population, has helped us digitize books through reCAPTCHA. Okay, and this type of number is what motivates my research. This is just one project that I've worked on. I worked on many other projects. But basically, the question that motivates my research is the following. If you look at humanity's largest scale historical achievements, these really big things that we've done throughout time, like, for example, building the pyramids of Egypt, or the Panama Canal, or putting the man on the moon, there's a curious fact about them. They all took about the same number of people, and it's about 100,000. That number is about 100,000 people. So all of these took about 100,000 people to do. Now, the reason for that is because before the internet, coordinating, let alone paying more than 100,000 people to work on the same project was virtually impossible. But see, now with the internet, I've just shown you a project where we've gotten 750 million people to work on the same thing. So the question that motivates my research is, if we can put a man on the moon with 100,000, what can we do with 100 million? And based on this question, let me tell you for the last 3 minutes about a new project that we've started working on. This is a project that we haven't yet released. And this is only the second time that I ever talk about it. Actually, the first time I ever talk about it outside of Carnegie Mellon. So I'll give you a little preview of what we're working on. This has not yet been released, so shh. Right. Okay, so here's how the project started. I started with the following question that I posed to my research group. How do we get 100 million people translating the web into every major language for free? So here's the thing. The web right now is partitioned into different languages. A very large fraction of it is in English. If you don't know English, can't access it. But it's not just the parts in English, a very large fraction of it is in different languages, and if you don't know those languages, you can't access it. So I would like to be able to translate all of the web, or if not most of the web, to every major language for free. Now, if you think you want to do that, you can imagine, well, why don't we just use computers? Try to get a computer to translate the stuff. Turns out that doesn't yet work very well. It makes a lot of mistakes. So computer translation just makes a lot of mistakes. And even when it doesn't make a mistake, because it makes so many mistakes, you don't know whether to trust it, because you don't know whether it's right or wrong. And even when it's right, the output that it gives is so screwy, so strange, that after you read about 3 lines of it, your head starts hurting. Okay, so computer translation doesn't yet work, and it's probably not going to work for another 15 to 20 years. Because we can't get computers, so we need to get humans. Now, the next question is, why don't we just pay professional language translators to do this? I mean, this seems like a very worthwhile goal, translate the whole web. Turns out that that would be extremely expensive. For example, if we wanted to translate only a tiny fraction of the web, so if we wanted to translate just Wikipedia into one language, into Spanish. So Wikipedia currently exists in Spanish, but it's tiny compared to English. It's about 10% of the size of English. If you wanted to translate Wikipedia into Spanish, from English into Spanish, it would cost about $50 million, even at the cheapest, sort of most exploited outsourcing rates in the world. It would cost about $50 million. It's a tiny fraction of the web. So I need to be able to do it for free. So this is the question that I posed to my research group. Now, if you have this question, you pretty quickly run into you realize there's 2 big problems. The first problem is that I don't even know, there's a lack of bilinguals. I don't even know if there exists 100 million people out there who are bilingual enough to be able to help us translate the web. The second problem that you run into is, how do you motivate people to do this for free? I mean, it's true that language translation is just something that you have to pay a lot for. So how do we motivate people to do it for free? Now, we got stumped on these 2 questions for a while, until we realized there's actually a way to solve both of these problems with the same solution. There's a way to kill 2 birds with 1 stone. And that is to transform language translation into something that millions of people want to do, and that actually helps with the problem of lack of bilinguals, and that is language education. So, for example, today, there are 1.2 billion people throughout the world learning a foreign language. People really want to learn a foreign language. And in fact, in the United States alone, there are over 5 million people who have paid over $500 for language learning software. So people really, really want to learn a foreign language. So what we're doing now is we're pretty much done building a website. It's called Duolingo, where the idea is people can learn a foreign language in this site for free while simultaneously translating text. The site, of course, is not yet live, but it turns out, so we're done building it, we're now testing it, and the crazy thing is that it works. Okay, so first of all, people actually learn a language by doing. They learn by translation, and they actually learn a language very, very well. And second, even more surprisingly, the translations that we collect are very accurate. They're in fact as accurate as professional language translators. And now to close, let me just give you an idea of how fast we can actually translate the language with this. So here are estimates. We can translate all of Wikipedia into Spanish. Remember, this is $50 million worth of material. We can translate all of Wikipedia into Spanish in 5 weeks with 100,000 active users, and in about 80 hours with 1 million active users. Now, since all the projects that I worked on before have gathered more than 1 million users, I'm very hopeful that we'll be able to translate text at a very, very fast pace. But I'm crossing my fingers, and I don't know. And that's all I have. Thank you.
Thank you, Luis. So computational power has exploded, but the genius of your approach is to combine computer and human intelligence. And where I first learned about you many years ago was when you developed the ESP game. And we've only got about 60 seconds, but can you tell us about the ESP game?
Yes. So that's a game that I made a few years ago. It's a game that people really, really like to play. There are people who play over 40 hours a week, this game. People really like this game. And as people are playing this game, the curious fact about it is as they're playing it, they're actually helping us to find what each image on the web is about, so that helps with image search. So for example, Google has image search. You know, computers cannot tell you what's inside an image. And in fact, the way Google image search gets a lot of its results is by people playing this game, where they're labeling all images on the web, and a lot of the results get like that. So I did that, and it's worked out pretty well.
Great. Thanks very much. Hand for Luis.